Assalamualaikum to our respected lecturer, Dr. SAIDATUL IZYANIE. We are from Group 7 from AC220E1F. We'll be presenting group assignment video on UCS433, Introduction of Blockchain, entitled Student Portal Companion, Student Assist Chatbot. Before we begin, let us introduce ourselves first. My name is Dalili Adlina binti Aisham.
Hi and Assalamualaikum. My name is Nurfarah Hanis binti Ali.
Hi, my name is Nurul Fatihah binti Razlan.
Assalamualaikum Binti. My name is Suraya Qistina binti Ain.
Before we dive into the discussion of the smart contract, let us know first what are the assignment selected use case, the issues prevailing, and the objective of the assignment. So, the selected use case that we have chosen for this group project is based on the educational field, which is regarding the Student Assist Chatbot. We have examined this use case as an interesting topic to delve into the issues that require the adoption of a Student Assist Chatbot. It is believed that the use case of a Student Assist Chatbot could serve as a valuable companion for students within a student portal. Firstly, the predominant issue in this particular use case is the lack of guidance for students' enquiries and administrative support. Most institutions and universities use the student portal as the primary platform for students to obtain all pertinent information regarding their courses and enrollment. However, there is still a deficiency in information dissemination, as students may have difficulty gaining access to the information and receiving assistance. This problem typically affects new students who are still adjusting to the institution's student portal system. This issue may remain unresolved indefinitely if the university student portal lacks integrated functionalities such as a chatbot that direct the users to the necessary information or provide further assistance. Furthermore, inconsistency in the information is an additional issue that frequently arises. Typically, universities rely solely on human representation, and in this instance, university personnel in order to support and distribute information to the students. However, people's knowledge, perception, and interpretation of university policies and procedures can vary considerably. Consequently, issues such as inconsistent information transmission may arise, which may lead to students to receive inconsistent information. Therefore, this issue will diminish the reliability and credibility of the presented information, as the students may consequently make poor decisions. From the issue arises, we have derived two primary objectives. Firstly, we aim to leverage the blockchain technology using smart contracts to implement Student Assist Chatbot as a solution to the issue. Also, in this presentation, we target to explain the smart contract for further understanding. Overall, this is the contract that we have created through the smart contract for the Student Portal Companion, Student Assist Chatbot. In this presentation, we will be describing the code elements by elements. The first line of elements in the code snippet is regarding the Software Package Data Exchange, or SPDX license identifier. SPDX license identifier is a standard format for identifying the license under which a piece of code is distributed. The SPDX license identifiers are used to represent the license type in a standardized manner, making it easy to comprehend the permissions and duties connected with utilizing the code. In this case, the MIT license is used. The MIT license is a permissive open source license that allows users to modify, distribute, and use the software for any purpose so as long as the original license notice remains intact. Due to its open terminology, the MIT license is suitable for both community developers and teams that wish to create proprietary software using MIT license code. Moreover, the next line of the code uses the Pragma directive to specify the Solidity compiler version. Pragma Solidity 0.8.11 indicates that the code should comply with any Solidity version compatible with version 0.8.11 or higher. The caret symbol, followed by the version number of 0.8.11, indicates that the code is compatible with any version in the 0.8 series as long as it does not introduce a disruptive change. It is essential to specify a compiler version to ensure that the code is compiled with the desired version and without compatibility issues. This is because the Solidity may introduce new language features, syntax, or enhancements that are necessary to ensure that the code complies with the intended version. Hence, through the specified Solidity compiler version, this will help to maintain consistency and compatibility across different Solidity versions and ensure that the code operates as intended. Now, I will pass the presentation to Nurul Fatihah.
In addition, the above code snippet hints at the existence of a Solidity contract known as greeting. This contract is made up of two public state variables known as name, which is responsible for storing the associated name, and greeting prefix, which is responsible for storing the default greeting message prefix. In addition to that, this contract makes use of string, which is a reference kind of data type in Solidity. This means that rather than actually storing the data into the variable, string stores the location of the data. You have the option of either manually assigning the strings with a text or providing them with an initial value that comes from the Solidity. Moreover, both the name and the greeting prefix state variables can be accessed publicly and are readable by other contracts or other entities because the type string is defined to be public. This indicates that the state variable of name, which is related with the greeting, is open to public reading in the same way as the state variable of greeting prefix, which is also associated with the greeting. In this particular instance, we have decided to set the greeting prefix to "Hello, what can I help you?" as a starting point to greet the individuals who is utilizing the chatbot assist function that is located within the student portal. Therefore, following the setting of a student's name, for example, Hana, the greeting contract of the chatbot function will display like, "Hello, what can I help you, Hana?" In addition, the constructor function in a Solidity contract is a unique function that is only run once the contract is being deployed. This is because the constructor function is a special function. When the contract is first put into use, its role is to either initialize the state variable or conduct any other setup task that may be required at that time. The constructor function in this snippet of code accepts a single parameter of the type string for the value of the initial name variable. In other words, it is anticipated that the initial name argument will be a string that reflects the initial value that will be assigned to the name state variable when the contract is initially deployed. In addition to this, the keyword memory specifies that the string parameter known as initial name is saved in the computer's memory. Nevertheless, the memory function in Solidity will only save function parameter data temporarily while the function is being executed. The data will be lost after the function has completed executing. Because the initial name parameter is a function parameter and not a lasting state variable, it will be briefly held in memory. In this case, since it is a parameter for a function rather than a state variable, when deploying the contract, we need to supply a value for the initial name argument in order to pass a string value that is surrounded by double quotes so that it can be executed the functions described above can be carried out. So for instance, if we deploy the greeting contract and supply the string Hana as the initial name, the line name equal initial name will cause the value of name to be set to Hana. This occurs because initial name is a variable that is set by the value of name. When the contract is deployed in this manner, it enables the users to customize the initial value of the name variable, and it also ensures that each instance of the contract will begin with a certain initial name. Depending on the contract's visibility, the name variable can be either be accessed and edited by using the setName function.
Thank you, Fatihah. So continuing on to the next line of code, the function keywords is used to declare a function inside of a contract. Meanwhile, the setName function is a public function that is contained within the greeting contract, which enables modification of the name state variable. For the execution, the setName function will assign the value of the new name parameter to the name state variable. Hence, the content of the contract may be effectively updated as the function will change the associated name that is stored within the greeting contract. Next, the getGreeting function in the greeting contract is a public view function that returns a greeting message as a string. This function allows the name and the greeting prefix state variable to be combined in order to retrieve the greeting message. The state of the contract will not be altered through invoking as indicated by the view keyword. In this case, external entities are allowed access to the contract which contains all of the data, but they are not allowed to make any modifications to them. Lastly, the abby.encodePack function is utilized to efficiently concatenate the greeting prefix and name strings. This function combines multiple arguments and concatenates them together in a tightly packed sequence of bytes, which is also known as byte array. This function can efficiently combine two strings without copying or allocating memory. However, in this case, we need the concatenated strings to be returned as readable strings rather than as encoded bytes. Thus, we utilize the string keywords to transform the byte array into a regular string before being returned from the getGreeting function. This will allow the users to receive greeting message as readable string. Now, I will pass to Farah to explain on the compilation and deployment of the smart contract.
Now, we will move on to compiling and deploying contracts. According to the provided figure, the first thing that has to be done is to correctly configure the compiler to match Solidity version 0.8.11 in order for us to successfully compile the contract. Next, under figure 2, it demonstrates that it is preferable to set the environment to Remix VM London while keeping the account and guest limit at their default values. After the contract has been created and has been set up, the subsequent step is to actually put it into use, which means we need to deploy it. But before we start to deploy the contract, we must put a name. Hence, for this example, let's use the name Hana to enter into the string variable known as initial name. Now, you can see it clearly in the picture shown here. As a result, the deployed contract will feature a getGreeting function that combines the greeting prefix and name state variable, resulting in the output, "What can I help you, Hana?" Furthermore, we can change the value of the name state variable. The setName function can be utilized by providing a new string value. For instance, now we use the name Bob in this contract. Consequently, now the greeting contract will no longer display "What can I help you, Hana?" but instead, it will reflect the updated name as "What can I help you, Bob?" Now, we will dive into our future outlook regarding this greeting contract. We have conducted a contract for greetings. However, we are strongly convinced that this function would be useful as a chatbot feature, especially in the educational field. We believe that it marks a big significant step towards making the idea of a chatbot companion realized in the future. When we first started to conduct this greeting contract, our goal was to create a chatbot that would be a student's friend and would help them along in their academic journey. Our aim is to also provide a flexible platform for students to address all of their questions and all of their concerns. This chatbot will deliver fair responses to all of the questions that student has asked without favoring anyone, and it is always accessible whenever and wherever. Furthermore, we envision adding more functionality to the code in the future to build a truly ideal companion chatbot. In addition to answering student inquiries, we also want them to view the chatbot as their reliable friend and they can turn into them into difficult situations. We aspire for this chatbot to provide assistance to students in all aspects of their life, supporting them through any difficulties they may encounter. We wanted our chatbot to provide emotional support to the students, especially in the form of encouragement and even assistance in finding resources for stress reduction or mental health care. Other than that, our idea is to make the chatbot to be equipped with time management and organization tools. This feature would greatly help the student as this chatbot will serve as their personal reminder. Students can manage their deadline, class schedule and assignment effectively. This will alleviate their workload and would provide them with better organization skills. So overall, we believe that a chatbot with various functionalities would help position our chatbot as an educational companion throughout the student's academic journey.